Dear children, welcome to this channel. In this video, let us continue the remaining examples using Vieta's formula. In my previous video, I have stopped with example 3.4. So, now let us start with example 3.5. Find the condition that the roots of the cubic equation x cube plus ax squared plus bx plus c equal to 0 are in the ratio p is to q is to r. See, you have to find out a condition using the roots where the roots are not given, but they are given that they are in the ratio p is to q is to r. So, let us take the roots to be, let the roots be as they are in the ratio, let us take the roots to be some pk, qk and rk, where k is a common value. Okay. So, whenever it is given in ratio, you shouldn't take the roots exactly as p, q, r. That means some common terms will be there and the common term will get cancelled. So, we have to take that one to be k. So, the roots will be equal to some pk, qk and rk. Okay. So, then using Vieta's formula, you have to find out first, let us find out the sum of all the roots. That is pk plus qk plus rk equal to, which is nothing but sigma 1 equal to, according to this it will be minus coefficient of x square, that is equal to minus a, as it is a monic polynomial, no need to divide it here. If there is any number, we have to divide it here. If the coefficient is other than 1, you have to divide it, otherwise leave it. Okay. So, it will be minus a. That is, this implies that k into p plus q plus r is equal to minus a. So, let it be equation number 1. Okay. And then sigma 2 is product of, this is nothing but the sum of the product of the roots taken 2 by 2. That is pk into qk plus qk into rk plus rk into pk, that is equal to the coefficient of x with the positive sign, that is nothing but b. Okay. So, let it be second equation. And then sigma 3 equal to the product of all the three roots, that is pk into qk into rk, that is equal to minus, alternative plus and minus, so it will take the minus and it will be the constant term, that is minus c. So, this implies that k cube into pqr is equal to minus c. So, let it be equation 3. So, from the 3 equation you are going to get a condition, right. So, k is the value what we have assumed. So, let us eliminate k from the equations. So, it is easy if we take the first equation and the third equation to eliminate k. So, eliminating k from the first equation and the third equation. So, here k is equal to minus a by p plus q plus r. So, we can even write that k is equal to minus a divided by p plus q plus r, and let it be equal to first equation. And here this k cube is equal to minus c divided by p q r, and let it be a third equation. Okay. So, now from equation 1 and 3 we have to eliminate k to get a condition. So, on substituting this value here, we have minus a divided by p plus q plus r the whole cube is equal to minus c divided by pqr, or minus a cube divided by p plus q plus r the whole cube is equal to minus c divided by pqr. Cancelling this minus we have, and cross multiplying pqr, we have a cube into pqr is equal to c into p plus q plus r the whole cube, and this will be the required condition. Okay. And this is the required condition. So, just apply the formula and then eliminate the constant k, so that you will get a condition which will be the required one. The next example 3.6, form the equation whose roots are the squares of the cubic equation x cube plus ax squared plus bx plus c is equal to 0. So, you have to form an equation whose roots are the square of the roots of this given cubic equation. So, first let us take the roots of the given equation to be alpha, beta and gamma, and you are going to find out an equation whose roots are alpha squared, beta squared and gamma squared. Okay. So let us take alpha, beta and gamma be the roots of the given cubic equation. Okay. X cube plus ax squared plus bx plus c is equal to 0. So therefore we have alpha plus beta plus gamma is equal to minus a. Then alpha beta plus alpha gamma plus beta gamma is equal to plus b, and alpha beta gamma is equal to minus c. Okay. So after taking the roots, immediately you have to write down what would be the sum of the roots and sum of the product of the roots taken 2 by 2 at a time and the product of the roots from the given equation, their value. And then you are going to find out an equation whose roots are alpha squared, beta squared and gamma squared. For that you need, let us take that sigma 1 to be the sum of alpha squared plus beta squared plus gamma squared. So to get its value you have to use these three. Okay. So as it is a square from algebraical quantity, it can be expressed as alpha plus beta gamma the whole squared minus of 2 into alpha beta plus beta gamma plus gamma alpha. Okay. So as alpha plus beta plus gamma is minus a, we can substitute here as minus a the whole square minus 2 into, and the value of this quantity is b. So that is nothing but b. So a squared minus 2b. So the value of sigma 1 is a squared minus 2b. Now let us find out sigma 2. Sigma 2 is nothing but the sum of the product of the roots taken 2 at a time. That is alpha squared beta squared plus beta squared gamma squared plus gamma squared alpha squared. So in order to get this value, again we are going to use the same identity, algebraic identity. Instead of alpha we have alpha beta, and instead of beta we have beta gamma, and instead of gamma we have gamma alpha. So again applying the same identity, this will be equal to alpha beta plus beta gamma plus gamma alpha the whole squared minus 2 into alpha beta into beta gamma. Okay. So first instead of alpha, alpha beta, and instead of beta, beta gamma is to be used. Then this 2 is common, plus beta gamma into gamma alpha plus alpha beta into gamma alpha. Okay. Now substituting, in order to substitute the value, here alpha beta plus beta gamma plus gamma alpha can be substituted as b. So this can be substituted as b, so it will become b squared minus. Here in order to get the value of the term inside the bracket, we can take one alpha beta gamma common from the three terms. So taking alpha beta gamma common, here the remaining term will be beta, and here it will be gamma, and here it is alpha. Okay. Substituting the respective values, we have b squared minus 2 into minus c into minus a, that is b squared plus minus 2ac. Okay, this is b squared minus 2ac. This will be the value of sigma 2. And then sigma 3. Sigma 3 is the product of the all the three roots, which is nothing but alpha squared beta squared gamma squared. This will be easily obtained by taking alpha beta gamma the whole square. Alpha beta gamma value is minus c, so it will be minus c the whole square, that is equal to c square. So after getting the values of sigma 1, sigma 2 and sigma 3, we can write down the required equation. Therefore the required equation is x cube minus sigma 1 into x squared plus sigma 2 into x minus sigma 3 equal to 0. Okay. So just to substitute x cube minus, what is sigma 1? Sigma 1 is a squared minus 2b. Okay. So a squared minus 2b into x squared plus sigma 2 is b squared minus 2ac into x, and then minus sigma 3 is c squared is equal to 0. So that's all. This is the required equation. Then next example 3.7. If p is real, discuss the nature of the roots of the equation 4x squared plus 4px plus p plus 2 is equal to 0 in terms of p. See, this is a quadratic equation, and you know the formula to find the nature of the root, that is discriminant, using the discriminant. So, what is the discriminant? It is denoted by delta, and it is nothing but the formula is b squared minus 4ac. Okay, and here what is b? A is nothing but the coefficient of x squared 4, and b is the coefficient of x, that is 4p, and c is equal to the constant term p plus 2. Okay. So, here a is equal to 4, b is equal to 4p, and c is equal to p plus 2. So, now let us substituting here to get the discriminant, b as 4p. So, 4p the whole squared minus 4 into a is also 4 into c is p plus 2. That is 4p squared is 16p squared, and here is also you have 16. So, taking 16 common, we have p squared minus of p plus 2, that is minus p minus 2. Okay. So, the value of delta is nothing but the product of 16 into p squared minus p minus 2. So, in order to discuss the nature of the roots, we have to find out the value of p, so that in terms of p only we are going to discuss whether it will be real. For what value of p it will be real, for what value of p it will be unreal, like that. Okay. So, let us factorize this. So, on factorizing, it will be p minus 2 into p plus 1. Okay, p minus 2 into p plus 1. So, using this, as it is a constant, 16 is a constant, we can leave it. In terms of p, we are going to discuss the nature of the roots. So, first of all, let us take a real line. So, here minus 2 and minus 1 means 0, and then for plus 1, that is, if the p plus 1 is a factor, means what would be the value of p? It will be minus 1, and p minus 2 is a factor, means it would be equal to plus 2, and here it is minus infinity plus infinity. So, we can split this into 3 intervals, that is minus infinity to minus 1, minus 1 to 2, and 2 to infinity. Okay. First, let us discuss the equality case. So, delta is equal to 0. When delta is equal to 0, you know that the roots will be real and equal. So, for what value of p it will be real and equal means, when delta is equal to 0 means p will be equal to 2 or minus 1. Okay, p will be equal to 2 or minus 1. So, at this point, exactly at this point 2 and minus 1, delta will be 0. So, right, first we can write, that means the roots are equal if p is equal to minus 1 or 2. Okay. So, the roots are equal if p is equal to minus 1 or 2. So, we have discussed one case, right, the equal, and then we can write a real and equal. Roots are real and equal if p is equal to minus 1 or 2. Then you have to find out for what value of p delta will be greater than 0. Okay. So, for that, for easy ways, you have to consider the number line and you have to consider 3 intervals. So, at this exactly at this point minus 1 and 2, p will be 0. So, you have to check at what interval it will be positive and what interval it will be negative in order to determine whether the roots are real as for what the and imaginary for the values of p. Okay. So, here choose the interval in which 0 occurs. Okay, in this interval minus 1 to 2, 0 occurs. On substituting p as 0, what you will have here, on substituting 0, p as 0, you will get 0 minus 2, that is minus, and here 0 plus 1 plus 1. So, minus into plus, that is negative into positive, it will be negative. So, whenever p takes a value between this interval minus 1 to 2, it will be negative. So, for all the values of p in this interval, it will be negative. This delta will be negative. So, automatically delta will be positive in the other 2 intervals because there is a partition. So, if it is negative means automatically the other 2 intervals it will be positive. So, when delta is greater than 0, p should lie between minus infinity to minus 1 and p should lie between 2 to infinity. Okay. So, when delta is equal to 0, greater than 0, minus infinity is less than p less than minus 1 and 2 less than p less than infinity. So, in these intervals only delta will be greater than 0. You should not put equal to sign here because when it is equal there will be delta will be 0. So, that is why simply less than. Okay. And then therefore, we can write the roots are real and distinct if this condition holds, that is minus infinity less than p less than minus 1 and 2 less than p less than infinity. Okay, so this is the condition for to get real and distinct roots. Okay, and then when delta is less than 0, so when delta is less than 0 means p should take the value between minus 1 to 2. So minus 1 less than p less than 2. Okay, so the roots are imaginary if minus 1 less than p less than 2. So this is the condition for the nature of the roots in terms of p. Next, let us start with exercise 3.1, the first sum. If the sides of a cubic box are increased by 1, 2, 3 units respectively to form a cuboid, then the volume is increased by 52 cubic units. Find the volume of the cuboid. Okay, this is the problem. That means a cubic units whose dimensions are increased by 1, 2, 3 respectively, then the corresponding volume of a cuboid will be increased by the volume of the cube by 52 cubic units. With the help of this condition, you are going to find the volume of the cuboid. Okay, so let us take x be the side of a cube, side of the given cube. Okay, so therefore what would be its volume? Volume is nothing but x cube cubic units, right? If each side, that is the side length, breadth, height are increased by 1, 2, 3 etc., then the resulting cuboid will be has the length x plus 1 and breadth will be x plus 2 and height will be x plus 3. Okay, so if the sides are increased by 1, 2, 3 units respectively, then the dimension of the cuboid will be, then the dimensions of the resulting cuboid will be x plus 1, x plus 2 and x plus 3. Okay, so what would be the volume of the cuboid? Volume of the cuboid is equal to length into breadth into height, that is x plus 1 into x plus 2 into x plus 3, right? That is nothing but x cube plus 1 plus 2 plus 3, that is 6 into x square, plus 1 into 2 plus 2 into 3 plus 3 into 1. That is the formula. So 1 into 2, 2 plus 2 into 3, 6 plus 3 into 1, 3. This will be the coefficient of x. So that is nothing but 11 x, and then plus last one is alpha, that is 1 into 2 into 3, that is nothing but 6. So this is volume of the cuboid. Now given condition is volume of the cuboid will be equal to 52 plus volume of the cube. Okay, so given that this x cube plus 6x squared plus 11x plus 6 is equal to volume of the cube plus 52. Right, it is increased by 52. The volume of the cube is increased by 52. So it will be equal to x cube plus 52. So from this we have to get the value of x. So cancelling this x cube on both sides and simplifying this, we have 6x squared plus 11x, then plus 6 minus 52 equal to 0. That is 6x squared plus 11x minus 46 is equal to 0. So this is a quadratic equation. So let us simplify this, we factorize this. Okay, so 6 into 46, 6 into 46, 6 6 36 and balance 3, 6 4s 24 plus 3, that is 276. So we have to find out the factor of 276 whose difference is 11. Okay, so in order to find this, let us find out the factors throughout by a division method. So 2 and here 1, 2, 3, 6 and then 16, 8. Again dividing it by 2, 6 and then 9 and then dividing it by 3, 21, again 23. So what are the factors? 2 into 2 into 3 into 23 will be 276. From that we are going to find out the factors in such a way that the product is 276 and the difference is 11. Okay. So, if you multiply these three, 2 into 2, 4, 4 into 3, 12. So, it will be 12 into 23 also equal to 276. And then if you take 2 into 2, it will be 4 into 3, 3 is 9, 3 to 6. That is 4 into 69 is also equal to 276. Like that we can find out the factors. Here 12 into 23 is 276 and 23 minus 12 will be 11. So, we can choose these two are the correct factors. Okay. So, 276 and this is nothing but plus 23 and minus 12. As the coefficient of x squared is 6 divided by 6. So, what will be the factors? 6x plus 23 into, and this is nothing but minus 2. So, x minus 2 equal to 0. So, these are the factors. So, what would be the value of x? X is equal to minus 23 by 6 or x is equal to 2. So, leaving the negative value, because x represents the side of the cube, we have to leave the negative value. So, taking the positive value, x is equal to 2, neglecting the negative value. Okay. And then what is the required question? You have to find out the volume of the cuboid, right? In the question, volume of the cuboid is asked. Okay. So, volume of the cuboid is to be found using this x. So, volume of the cuboid is nothing but x cube plus 52. So, that x cube plus 52 where x takes the value 2. So, 8 plus 52 that is equal to 60 cubic units. Okay. In your book it has been given as 8, that is volume of the cube is given instead of the volume of the cuboid. So, take it as 60 cubic units as the correct answer, right? Then third one is, if alpha, beta, gamma are the roots of the cubic equation x cube plus 2x squared plus 3x plus 4 equal to 0, form a cubic equation whose roots are, the first subdivision is 2 alpha, 2 beta, 2 gamma, second subdivision is 1 by alpha, 1 by beta, 1 by gamma, and third one is minus alpha, minus beta, minus gamma. Okay. So, these are very simple problem. I am going to do the second subdivision alone. So, first to start with, what you have to do, given alpha, beta and gamma are the roots of the cubic equation x cube plus 2x squared plus 3x plus 4 is equal to 0. You have to find out sigma 1, sigma 2 and sigma 3. Okay. So, what is sigma 1? Sigma 1 is nothing but sum of all the 3 roots. So, that is equal to minus 2. And sigma 2 is equal to sum of the product of the roots taken 2 at a time, that is alpha beta plus beta gamma plus gamma alpha, that is nothing but 3, alternative minus plus, right? And sigma 3 is nothing but product of all the 3 roots, that is alpha beta gamma, which is equal to minus 4, right? So, after getting the value of sigma 1, sigma 2, sigma 3, we are going to use this in order to find out the equation whose roots are this one, right? See, the second subdivision is you are going to find out a cubic equation whose roots are 1 by alpha, 1 by beta, 1 by alpha, 1 by beta and 1 by gamma. Okay. So, to derive the equation with these roots, first of all you have to find out sigma 1 for this, that is sigma 1, that is nothing but sum of all the 3 roots 1 by alpha plus 1 by beta plus 1 by gamma, right. So, that is by taking LCM you will have alpha, beta, gamma, and here beta gamma is to be multiplied. So, beta gamma, and here to get this LCM alpha and gamma is to be multiplied, and then this will alpha beta is to be multiplied. And you know alpha beta plus beta gamma plus gamma alpha, the value of this one, and alpha beta gamma from the given equation, right. The value of this is 3 and alpha beta gamma is minus 4. So, sigma 1 takes the value minus 3 by 4, okay, minus 3 by 4. Then sigma 2, it is nothing but sum of the product of the roots taken 2 at a time. So, 1 by alpha into 1 by beta plus 1 by beta into 1 by gamma plus 1 by gamma into 1 by alpha, okay. So here also let us take the LCM alpha, beta and gamma. So here to get this LCM, gamma is to be multiplied and therefore gamma, and here alpha is to be multiplied and therefore beta. So the numerator is alpha plus beta plus gamma and its value is minus 2. And the value of alpha, beta, gamma is minus 4, that is equal to 1 by 2. Okay. Then sigma 3 is nothing but the product of all the three roots, that is 1 by alpha into 1 by beta into 1 by gamma. So this is nothing but 1 by alpha, beta, gamma. So 1 divided by minus 4, that is nothing but minus 1 by 4. So after getting the value of sigma 1 and sigma 2 and sigma 3, we can write down the required equation. So what is the required cubic equation? X cube minus sigma 1 into x squared plus sigma 2 into x minus sigma 3 is equal to 0. So that is x cube minus what is sigma 1? Minus 3 by 4. So minus 3 by 4 into x squared, and then plus sigma 2 is 1 by 2. So 1 by 2 into x minus sigma 3 is minus 1 by 4 equal to 0. So always you should get integer coefficients. So you have to multiply throughout by the LCM of the denominator, which is 4. So on multiplying by 4 throughout, we have the equation as 4x cube, and here minus into minus it will be plus 3x squared, and here plus 2x, and then plus 1 is equal to 0, and this is the required equation. Okay. See, in the same way you can try the first subdivision and the third subdivision, which is very simple. So for that you have to use the value alpha plus beta plus gamma, and alpha beta plus beta gamma plus gamma alpha, and alpha beta gamma wherever necessary. Okay.